Hey guys, Mr. Backer here. In this video, we're going to look at cofunction identities. Now, as we're talking about cofunction identities, I want to start by taking a look at a right triangle. So obviously in a right triangle, we know that we've got ourselves a right angle, and we also know that the angles inside of a triangle are supposed to add up to 180 degrees, meaning that these two acute angles in here would have to add up to 90 degrees. So if I call this angle A, and I'll call this angle up here B, and let's call this right angle C, I'm going to call this side going across the bottom X, this I'm going to call Y, and then my hypotenuse I'm just going to call H. So if I wanted to do the sine of angle A, well, we know that sine is opposite over hypotenuse. So that's going to be Y over H. And if I wanted to do the cosine of angle A, then that's going to be the adjacent side X over the hypotenuse H. And if I wanted to do the tangent of angle A, well, tangent is opposite over adjacent. So that would be Y over X. And then I could also do my reciprocal functions as well. So the cosecant of A would be the hypotenuse over Y. The secant of A would be the hypotenuse over X. And then the cotangent of A would be X over Y. But if I wanted to shift my focus to angle B instead, and I wanted to do the sine of angle B, then now the opposite side is X, and my hypotenuse, well, that's still H, so I get X over H. And notice we had this fraction show up earlier. That was the cosine of angle A. Or if I wanted to do the cosine of angle B, well, cosine is adjacent over hypotenuse, so now the adjacent side is the Y, hypotenuse is still H, and again, we've seen that fraction before. That was our sine of angle A. If I wanted to do the tangent of angle B, well, opposite of angle B is X and adjacent is Y. And again, we've seen these fractions before. The tangent of B is the same as the cotangent of A. And then again, we can do those reciprocals as well. So the cosecant of B would be H over X. The secant of B would be H over Y. And then the cotangent of B would be Y over X. So what we should be noticing is that, like, the sine of angle A is the same as the cosine of B, or the cosine of A is the same as the sine of B. The tangent of A is the same as the cotangent of B. So what we've got in here is a relationship between these acute angles. And like we mentioned earlier, these two angles, A and B, because they're inside of this right triangle, have to add up to 90 degrees. And back in geometry, we call the set of angles that add up to 90 degrees, well, we call those complementary. And that's where we get this idea of co-functions. The co in cofunction means complementary. So the relationship that we're establishing between these, if we wanted to look at the sine of pi over 2 minus theta. Remember, pi over 2 means the same as 90 degrees, but it's a radian angle. So the sine of pi over 2 minus theta is going to equal the cosine of theta. And it's because of the co-function relationship that we saw within those triangles. Similarly, if we wanted to look at the cosine of pi over 2 minus theta, then that's going to equal the sine of theta. Our next cofunction identity says if we have the tangent of pi over 2 minus theta, then that's going to equal the cotangent of theta. And we could also reverse that one to say that the cotangent of pi over 2 minus theta, that's going to equal the tangent of theta. And then if we took the secant of pi over 2 minus theta, that's going to equal the cosecant of theta. And again, we can reverse this one around to get the cosecant of pi over 2 minus theta equals the secant of theta. So each function, like the sine, has a cofunction, which we call the cosine. Tangent has a cofunction, which we call the cotangent, and secant has a cofunction, which we call the cosecant. And again, those relationships can also be reversed. Now, we looked at it using a right triangle example, which involves just acute angles, but these relationships do extend beyond those acute angles into some obtuse and even larger oblique angles as well. That's going to be it for this video. Thanks for watching.